G'day everyone. Well, for today's autopsy I figured we'd have a look at the regulator valve out of a gas water heater. Ours carked it a while ago. It started leaking out of one of the inlet ports for the water, and as a result of that it had to be replaced. But the good thing was that the guys who pulled it out left the old one behind, so I was able to pull a ton of good parts off of it, including this. I got the burner rack, got the piezo igniter, and also a ton of copper pipe, so that'll be good for funding some future projects. I might even make a little gas burner out of the rack from it. It's all in pretty good nick actually, so but just for the hell of it, I'd figured I'd open this thing up and just see what's inside it, because I don't really know much about this sort of stuff, but I just figured we'd have a look inside on how it actually works. I'm presuming this will be a thermocouple of some sort, but this goes into the tank. It screws on here. It's just a threaded union, and that just goes into a female on the tank. But that's your gas control there, so you 1 to 5, depending on how hot you want the water or how big you want the flame. It's got a that must be ignite pilot light sort of thing. But anyway, I'll get our Torx driver onto it and we'll get some of these couplers and things off and just have a look inside it. Well, there's that probe off. I suppose you'd call it that. It's those two copper tubes are actually soldered onto the end of this, so I may just end up chucking that in the incinerator just to melt the solder and get the copper off the brass. But anyway, that's actually what was up the middle of it. It's a little Klickson device. That's a thermal overload switch. Usually you find that sort of thing varnished into electric motor windings. Okay, got the top cover off this thing, and there's a rather interesting mechanism inside it, which is going to involve a bit of explaining on how it works. It's basically composed of a series of springs and valves, which are designed to regulate and divert the flow of gas through these chambers, which are all through it. You got one big one here and then another one here. There's the gasket for it. That sort of shows that, yeah, you put that on and it clearly outlines where the chambers are in it, but it's fairly straightforward in terms of where gas is actually going on this. You've got a solenoid here, which is actually what's attached to the Klickson device. So when that would be cold, like when the unit's first turned on, this would pull that little piston in, and there's a valve up inside here which that is attached to. Now that valve, which is around here, is also attached to this knob here, which is the manual ignition, and you can push that in. That'll allow gas to flow into this chamber here from here. That's the intake. Now it doesn't actually come out through here. There's just the blanking nut that goes on it to hold it in there. But it goes through this CAD plated steel screen, which is also up inside there and surrounds the solenoid. So once it comes through there, it then goes into here, all through this chamber here, past this non-return valve up here, which has also a cam on this shaft on the knob, so it can actually be pushed open and shut depending on what the settings are. But this valve head's also attached to a rubber diaphragm down there, which is what that steel plate is under there, that which has got 3 Torx screws on it. But I'm guessing that'll have something to do with how high this valve head comes up and down inside its housing, and that will probably regulate the amount of gas that then flows through to the next part, which is here, which has another check valve with a little spring-loaded pin, which has probably got another diaphragm on there, which is pushed up to push this valve up, which allows gas to then go down through that chamber there and out to the burner rack. There's also a secondary route as well, which is down through here, through this moisture absorption pad of, I think it's moisture absorption or filtering or something. Then down through a little hole down there and out of here, and that goes to the pilot light hose. It's fairly straightforward actually. There's not really much inside the top housing apart from the chambers, which you can actually see clearly outlined here. But it's fairly straightforward. You got calibration or something, I'm guessing these are for. You got little springs on the end. But next thing I'll do is get that off. Is take this back off and just have a look at what that diaphragm thingy is down there, which you can actually see a bit better now. But yeah, there's a rubber diaphragm which is attached to that valve head there. We'll have a look at that next. Well, I got that steel end plate off. There definitely is a diaphragm inside there. It's got a little brass washer or retainer holding it on. Well, that little plastic split pin end is the end shaft of the valve. But there's actually a tiny little hole in this end plate right there. So I'm guessing that may be I'll just focus out. That may be air escapement or something, I'm not 100% sure, but yeah, as I push on it you can see it's pushing that valve in and out. I can even move it. So it's all reliant on the movement of this to push it in and out. That may be a vacuum chamber or something that's forming, and it's just that pushes out, and as it slowly lets air out, it slowly allows the valve to drop back down or something. I'm not 100% sure on what. But yeah, interesting thing. There's not really much point trying to pull it out. It looks like there's another brass retainer down inside there, so I don't really want to try busting this thing up. Not that I can actually use it again, because I've already broken the seal between the gaskets, so it's not actually any good for gas use again, but it's interesting enough just having it as a display piece. Might just stick the solenoid and everything back in and just keep it as it is. But anyway, hope you enjoyed that. Thanks for watching.